Khufu has just died. The boat that we flew over in the harbour has just transported his remains into this temple, called the Lower Temple or Temple of the Valley. Here we can see the body of the king under the purification tent, where it's washed down. This is the first step of a slow preparation, 70 days, necessary for Khufu to be reborn and achieve eternal life. These steps will be performed in succession at 4 points in the funerary complex. The Lower Temple, where we are now, then the Royal Causeway we are flying over now, connecting the avenue to the Upper Temple, and lastly, the pyramid in which the king will be buried. Here it is, this fine pyramid, the seventh wonder of the world, dominating the plateau with its 146 meters of immaculate limestone. This is a master coup, but it's not a first attempt. In fact, one does not get to design and build such a masterpiece by chance. Khufu's pyramid is part of a well-established tradition of funerary architecture. The Egyptians continued to improve their construction technology right from the very first pyramid. The stepped pyramid of King Djoser, Snefru, the father of Khufu, had 3 built, with smooth sides, including the Red Pyramid, which immediately preceded that of Khufu. This is a magnificent pyramid, smaller and less steep than the Great Pyramid, but its plan is very pure. The distribution of the funerary chambers is straightforward, a descending corridor, 2 antechambers for the funerary furniture of the deceased, and a chamber in the mass of the pyramid. All these chambers are covered with a corbelled vault, that is to say, a vault constructed of rows of stones that become closer with increasing height and capable of supporting enormous vertical loads. The Egyptians had mastered this technique a long time before. The distribution of the corridors and internal installations is in line with what is observed in the previous pyramids. And here is the Pyramid of Khufu, higher, steeper, and with an internal layout that is a total departure from previous pyramids. There are 3 funerary chambers. The first, dug very deep into the bedrock and remaining unfinished, the second in the mass of the pyramid, and a final chamber at 1/3 of the height. This chamber is extraordinary, not only because of its location between 43 and 64 meters high, higher than anything known before, but also because it possesses a flat ceiling and 4 false ceilings beneath the roof of limestone rafters. We will see that this choice of a flat ceiling profoundly influenced the structure of the pyramid and its method of construction. One could even say that it was a determining factor. As for the corridors, they are more numerous than in the Red Pyramid, some branching off from the funeral chambers with quite a tortuous geometry. Finally, there is this enormous oblique structure, the Grand Gallery, unique in the architecture of the pyramids. Such a revolution is astonishing, the Egyptians having previously developed their technology gradually from one pyramid to the next. To sum up, the Khufu pyramid presents us with 2 enigmas, one in its construction, and then the one of this evolutionary leap. To construct a pyramid, it's necessary first to choose a suitable location and establish an infrastructure. On the Giza Plateau overlooking the Nile Valley, the Egyptians find an ideal location, quite large, gently sloping, and with limestone in abundance. They start to build the infrastructures there. They have to establish lines of communication and transportation for the stone. They dig the necessary canals to transport the stone, including Tura limestone, extracted from the east bank of the Nile, and Aswan granite, quarried 900 kilometers south of Giza. There, they have to house the workers. There will be about 4,000 people working permanently on the site. First, there are the construction professionals, architects, foremen, masons, carpenters, and other qualified workers. There are also the seasonal workers, for example the peasants who come to carry out a sort of pyramid duty while their fields are inundated by the flooding of the Nile. Assigned simple tasks like handling materials, they're paid in kind, food and drink, and earn their place in eternity in contributing to the building of their king's eternal monument. Finally, there are the ancillary services and all their trades, toolmakers and repairers, butchers, bakers, fishmongers. Contrary to later popular belief, there are no slaves. Constructing the pyramid is an enterprise that is both religious and social. It is the big state project that unites Upper and Lower Egypt in one common venture. Besides the canals and the towns, 2 ports are required. A commercial port for the ancillary services and a port to receive the construction materials, which we're flying over now. And here are the red granite beams from Aswan. The Egyptians extract them by striking the stone with balls of dolerite, a material much harder than granite. This is very long and very painful work. These beams were ordered right at the start of construction and will not be installed until 14 years later. Extraordinary proof of anticipation and planning. You can see now the limestone rafters from Tura that will top various chambers in the pyramid. This very beautiful, fine white limestone will also be used for encasing the monument. And right here are the limestone blocks from Tura, which would form the skin of the pyramid. This limestone had a special characteristic. It was very soft in the quarry, but hardened quickly on contact with the air once mined. Because the Egyptians did not yet know how to forge iron, the hardest cutting material they had available is copper. Therefore, they had to cut the soft stones immediately to their final form, complete with beveling. These casing stones were then numbered and shipped to the work site, a perfect example of prefabrication. We look back on the 5th year of construction, which also corresponds to the 5th year of Khufu's reign. The materials that had arrived at the port would now be transported along a wide causeway leading to the work site that we can see in the distance. The causeway, which we will call the port ramp, had a gentle slope of about 8% and ample width, enough for the massive supplies required for the work site. Following the topography of the plateau, it ran judiciously through the middle of other quarries, providing limestone that was of a lesser grade than that from Tura, but was abundant on the plateau. They would supply the major part of the materials for the pyramid. Here in red, we see the route taken by the granite beams. In mauve, the route used to transport the limestone extracted from these quarries that are starting to be exploited, and in white, the route used for the limestone supplies from Tura. You see that the quarrymen were working on smooth surface stones and more crudely cut stones at the same time. We will soon see why. As the wheel did not yet exist, the stones were transported on wooden sleds, an example of which can be seen in the Cairo Museum. The blocks of local limestone would then be pulled up a second external ramp, which we'll call the pyramid ramp. About 325 meters long, with a slope of 8%, it was built with the same limestone taken from the local quarries. This ramp had 2 lanes, one to allow the stones to be transported, the other in the process of being raised in height. The pyramid was constructed in successive horizontal layers called courses. During the construction of one course, the ramp was elevated to prepare for the construction of the next course. In this manner, construction never stopped, the ramp and the pyramids progressing together. As for the Tura limestone blocks intended for the outer casing, they followed a very different route. They were transported via an internal ramp, also with a gentle slope, constructed behind the pyramid's surface, starting from its base. Here we can see the entrance. This internal ramp constitutes the principal idea behind Jean-Pierre Houdin's theory, the construction of the pyramid from the inside. This is the principle. The Tura casing stones were laid first. Remember that they had been cut side by side at the quarry and numbered. So they only had to be laid according to their numbers, rather like the pieces of a model, to construct a perfect casing right from the start. There was therefore no need for facing at the end of construction, which represented a great saving of time, especially when we consider there were 84,000 square meters of casing. When this was done, there was an enclosed working area into which the cut blocks of local limestone were brought by way of the external pyramid ramp for the construction of a second belt about 20 meters thick. This structure gave the pyramid its solidity. It's these stones that can be seen today, the Tura limestone having been removed in the Middle Ages for the construction of the monuments at Cairo. Once this finely finished structure was in place, there was no longer any need for such fine construction. Speed was of the essence. The center of the pyramid was thus filled with very roughly hewn stones, blocked with quarry rubble, and often. There was one exception, however. This sort of finely finished, peninsula visible in the middle of the infill. This was to serve as the foundations on which all the internal works, as the Grand Gallery and the King's Chamber, would be constructed. Given their importance, it was out of the question to build such structures without solid foundations. The Egyptians were also smart. They constructed the pyramid in another limestone quarry. The terrain having a slight slope, they kept a section of bedrock about 7 meters high. This light patch that we can see at the top right inside the monument. Only the bases of the casing stones were leveled at the start of construction. The pyramid was thus anchored solidly on this natural foundation. In doing so, they used almost 400,000 tons of limestone that was already on site. The Egyptians thus continued to construct the pyramid in successive courses from level 7 to level 43, that is, from 7 meters to 43 meters high. At level 43, the volume constructed represents about 2/3 of the volume of the structure. The Egyptians supplied the worksite with local limestone using the external ramp and transported the casing stones of Tura limestone up the internal ramp, the start of which we can see on these images from the CATIA 3D scientific software. In about the 14th year of the king's reign, the construction having progressed well, the pyramid reached a height of 43 meters. The construction from the inside, that is, inside out, left the rest of the Giza plateau totally free. This was important because the other monuments of the funerary complex could be constructed independently. We can see the beginning of the construction of the upper and lower temples and the royal causeway. Moreover, as deaths occurred in the family and those close to the king, mastabas were constructed nearby to receive the deceased, and even small pyramids for the Queen Mother and the king's wives. The Great Pyramid slowly became the center of a veritable necropolis. On reaching the base of the king's chamber at 43 meters, the construction process needed to evolve. With the Great Pyramid, there were 3 challenges in one monument: the volume, the king's chamber, and the height. 14 years had been spent successfully tackling the volume challenge. Now came the second challenge. The choice of a flat ceiling for the king's chamber obliged the Egyptians to use granite, the only material strong enough to span the 5-meter width of the chamber. There were also 4 further ceilings above the first before the chamber was covered with a roof in an inverted V-shape consisting of limestone rafters. The room therefore reached 21 meters in height in stages, from level 43 to level 64, which was unique in the architecture of Egyptian pyramids. Here we see the floor of the chamber, made from heavy slabs, and the northern wall, all of granite. Close to the southern face, we can see the rafters and several beams on a storage area. It would be necessary to lift 50 granite beams and 22 limestone rafters to level 43, and then position them in their final location. That was the big challenge of the king's chamber. How did they transport them to this height? To hoist monoliths weighing up to 63 tons to this level would need several hundred men. Quite simply, it would have been impossible to coordinate so many workers, and it would have required a lot of room for them to pull it up. Now, because of the shape of the pyramid, the higher one climbed, the less space there was. They had to think of another solution. All the granite beams extracted by the Aswan quarrymen arrived at the port, where they were stored. The beam was borne on a sled that rolled forward on logs. Past masters in balancing games, the Egyptians invented a device to reduce the effort required by the workers to move the monoliths. It was a counterweight, similar to that of an elevator. At the end of the port ramp, they dug a trench into which a counterweight descended. Linked by lengths of rope to a sled on which the beam was loaded ready for transport by rolling on logs, this counterweight essentially supplied the tractive force. The depth of the trench was calculated so that, once the counterweight reached the bottom, the beam moved a distance equal to 1 rope length. They just had to block the beam, remove this length, lift up the counterweight, reattach the ropes, and start the operation over again. The port ramp would later be used as the foundation for the royal causeway of Khufu's pyramid. Signs of this counterweight and the trench can be seen in the access corridor to the Khufu's funeral. The beam was transported in this way to the foot of the pyramid's external ramp. It was then rotated a quarter turn, still on wooden logs. The beam was hauled by a second counterweight that raised it on the external ramp to the 43-meter level, where it was stored, waiting to be used. The second counterweight travelled in a structure built at the same time as the pyramid in its heart, the Grand Gallery. Here we can see the ropes descending into the Grand Gallery, which remained partly in the open air. It's been suggested that this structure had a religious, funerary, or even symbolic role. It's alleged to have served for the funeral of Khufu, or even to have symbolized a ramp for the king's ascension to the gods. If such were the case, one would expect to see inscriptions or ornamentations indicating such a purpose. But there is not one. The Grand Gallery's purpose was exclusively as an aid to construction. The beam was thus hoisted to the pyramid's working level, 43 meters above the ground, by means of this second counterweight. Some months had passed, and the granite beams and the limestone rafters required for the construction of the king's chamber were now all arranged in the new storage area on level 43, ready for the next step. The external ramp was now at its maximum height. The construction of the king's chamber had begun with the laying of the floor. Now the walls and ceilings needed to be built. There again, the counterweight in the Grand Gallery played a major role in helping to hoist the beams from the storage area to their final position. The Egyptians thus constructed the 5 successive ceilings of the king's chamber, a project that was unique in Egyptian architecture. For this, a cross-sectional view will be more practical. We have made all the surrounding stones transparent to make the important elements stand out. Moving around in the Grand Gallery, we see the counterweight, a wooden sled loaded with several blocks of granite weighing around 25 tons in total. The principle is that of the funicular railway. When the counterweight descended, the beam on its platform at the opposite end rose to the desired height. To limit friction, the Egyptians used a train of cedar logs kept in alignment by a wooden structure which travelled up the steep slope of the Grand Gallery. The counterweight frame moved on these rollers, which rotated as it passed. The system has been simulated with Dassault Systèmes scientific 3D solutions, showing no problem with friction. With the assistance of the counterweight, only an estimated 180 workers at the most would have been needed to hoist the granite beams, including the heaviest one of 63 tons. An old bas-relief illustrates the transportation of a statue of more than 60 tons with a similar number of workers. So the idea appears quite feasible, historically as well as mechanically. When the granite beam arrived at its destination, the counterweight was at the bottom position in the Grand Gallery. It had to be lifted back up for a new lifting operation. The beam-carrying platform was then ballasted with around 15 small stones of 2.5 tons, easy to move, a sufficient load to reset the Grand Gallery counterweight. The platform thus became the counterweight's counterweight. Once the rafters were in position, the counterweight was dismantled and the 3 main ballast stones were lowered to the bottom of the ascending passageway to prevent access by robbers. For this reason, they're called ceiling blocks. There are many signs to support the use of the Grand Gallery as the counterweight slide path, available in the clues section of the website. Let's see now how the Egyptians constructed the ceilings of the king's chamber. In about the 16th year of his reign, the 3rd ceiling was reached, of a final total of 5. From the storage area on level 43, the beams were hoisted to their final height by use of the counterweight. They were then hauled into place and installed side by side to form this ceiling. Each new ceiling in the king's chamber was constructed at the same time as the course of the pyramid at the corresponding height. In this way, the pyramid's construction continued to advance at the same time as the king's. The Egyptians continued delivering the blocks of local limestone by the external ramp and the casing stones by the internal ramp. This internal ramp will emerge in the southwestern corner and continues from the southeastern corner. Between the two, the teams pulled the Tura stones horizontally along the edge of the storage area, which enabled them to continue using the exterior ramp. There is nevertheless one oddity during the whole length of construction of the king's chamber. The need for a storage platform at level 43 caused the temporary stoppage in the construction of the internal ramp close to the southern face. The storage platform at level 43 remained in service until the end of construction of the King's Chamber. The goal was to avoid impeding the massive transportation of stones that was still in progress on the external ramp in order to supply the pyramid's construction. The external ramp reached its maximum height at the level of the storage area. The Egyptians extended it with a ramp in an open-air trench along which we can now follow this stone. This trench climbed within the body of the pyramid, making a quarter turn in the opposite direction to that of the internal ramp. Obviously, the spiral tightened as it climbed, and as in the video game Snake, the snake would finish by biting its own tail. At a height of nearly 70 meters, this ramp had to end. Nevertheless, using this ramp and the external one, the Egyptians constructed 85% of the total volume. At this stage, two construction phases were finished, the volume and the King's Chamber. Now was the time to move to the third and final challenge, the height. First, let's summarize what we've just seen using CATIA. First, the storage area for the beams and rafters at level 43 at the top of the external ramp, which continued in a spiraling trench. At level 70, the rafters were installed to finish the King's Chamber. The spiral trench and the storage platform at level 43 were filled in and leveled. The two openings of the internal ramp behind the southern face were connected by a horizontal segment. This is thus the only segment of the internal ramp that does not rise with a gentle slope of 7%. This was the price paid for being able to use the external ramp to the maximum by extending it in a trench. It was worth the penalty, since there only remained 15% of the volume to construct. 15% of the volume, yes, but still a little over half the height. The question was now how to reach the summit and finish the pyramid. The answer? The internal ramp. At a height of 70 meters, space was limited, and the blocks were now a lot smaller, from 500 kilos to 2 tons, and so could pass through this rather narrow tunnel. We should also remember that the external ramp, whose role had come to an end, was constructed of quality limestone. Therefore, it represented a reserve of materials that were ready to use and, what's more, ideally placed. The Egyptians now dismantled this external ramp, recut the stones, and raised them via the internal ramp from its entrance at the base of the pyramid. Two types of stone would travel through the internal ramp from now on: the Tura casing stones and the recycled stones from the external ramp. We can see in these CATIA images how the external ramp diminished while the Egyptians finished the pyramid, according to the principle of connected vessels. This is the reason that no trace of the external ramp has ever been found on the Giza Plateau. It is, right before our eyes, recycled in the upper part of the pyramid. A last clever move by the Egyptians. Proof, as if it were needed, of their great intelligence and careful planning of the construction of the Great Pyramid. But let's now follow this block up the internal ramp. We can see that the workers had just one thing to do: pull the stone in a straight line up the gentle 7% slope. The ramp, as in the segment where we are located, was lit by oil lamps. Open at both ends, it was ventilated naturally, which provided proper working conditions. When it reached the end of a rectilinear segment, the block was rotated a quarter turn, again using a system of counterweights. This system was derived from the ancient shaduf, or counterpoise lift, that the Egyptians used to draw water from the Nile. Already perfected at the time, this system enabled a single man to raise the stone and its sled. The whole thing was then turned 90 degrees to line it up with the new section, then laid down again, ready to be taken care of by another team of workers who transported it up to the next point of rotation. The corner chamber, in which we've just seen the block being rotated, was located behind a notch on the northeastern ridge of the pyramid. Explored by the American Egyptologist Bob Breyer, it was completely recreated with Dassault Systèmes 3D solutions. See this subject in the clues section on the website. Thus, the block passed through the internal ramp and was rotated at each corner in a chamber similar to Bob's room. The workers we've just seen depositing the block to be rotated, then returned to the start of the flight to get another. They used this ladder and went back down using the upper level of the internal ramp taking an empty sled with them, which had been left by a team from the following section of ramp. The Meidum Pyramid proves that the Egyptians know how to deal with an intermediate floor in a structure covered by a corbelled vault. This two-level ramp meant that a returning team with an empty sled did not impede the ones that were ascending with a new stone, so that no construction time was lost. Here we follow the journey of the workers and take the upper level of the ramp back down. Now here we are outside. The exit of the ramp is right beside the entrance. Here are two photographs, one recent and the other older, where the lighting reveals what could be the entrance and exit of the internal ramp. You can clearly see a rectangular zone where the stones are not installed in the same way as elsewhere, and the shape revealed seems to correspond to the supposed ramp openings. Moreover, a French mission conducted in 1986 under the aegis of the EDF Foundation studied the pyramid using microgravimetry. This technique serves to detect voids and is often used by EDF to check for the absence of underground cavities, for example at locations where high voltage pylons will be erected. The technique was used here to look for an unknown room. Here we can see a plan view of the pyramid with the internal ramp proposed by Jean-Pierre Houdin superimposed on the image of the microgravimetric readings from the 1986 mission. The green zones represent areas of very low density in comparison with the red ones, in other words, potential voids. One notices a disconcerting resemblance to the drawing of the internal ramp. The yellow segment corresponds to the horizontal segment of the ramp at level 43, and the circle at the top in the right-hand corner to the room explored by Bob Breyer, known as Bob's Room. In this 3D view, the matching of the microgravimetric image with the internal ramp of the theory is even more striking. This series of corroborating indicators was encouraging, but only on-site investigations dedicated to the location of the internal ramp would definitively establish the validity of Jean-Pierre Houdin's theory. He has always favored non-destructive techniques. Interfering with the pyramid would be out of the question. Jean-Pierre first envisaged microgravimetry or surface radars. Then the Dassault Systèmes teams simulated the effect of the sun on the model of the pyramid without the internal ramp and then with the ramp. These simulations showed patterns of sufficient temperature differences to make it a good candidate for infrared thermography. Moreover, a team from Laval University in Quebec City is working with Dassault Systèmes to follow this promising trail. The pyramid was now finished. We know from written records that Khufu was definitely buried there. Which brings us back to the second enigma, that of his funeral. On this cross-section of the monument we can see the route of the funeral procession traditionally put forward. Entering by the descending corridor, the procession turned sharply to climb the ascending corridor. This already poses a problem because of the length of the sarcophagus. It then followed the grand gallery and its very steep slope, which would have made progress difficult, to reach the chamber with the portcullis slabs, and then, finally, the king's chamber. This chamber had to be sealed after the ceremony, and it's here that the principal problem arises. The block used for this purpose is shown in this photograph, next to a person to show the scale. It remained inside the chamber for almost 1,200 years, until it disappeared during restoration work in 1998. This block can only have been put in place from within the chamber. It's slightly too big to have come through the grand gallery, and to have travelled through the small passage crossing the chamber with the portcullis slabs. Then there's a big problem. It would have taken about 10 workers to push this stone in order to close the chamber, which means that these unfortunate workers would have been walled up alive. This was not at all in the Egyptian funerary tradition. Moreover, Caliph al-Ma'mun, responsible for opening the chamber at the time of an expedition in around 820, found only a single body, the mummy of Khufu, in the sarcophagus. The commonly accepted route for the funeral, therefore, appears totally unrealistic. But in this case, what route did the funeral procession take? How was the chamber sealed? And how did the officiants and workers leave after the king's burial? This is what we'll attempt to understand, but first, let's go back to the preparations for the ceremony. Let us return to the lower temple where we left Khufu in the purification tent. The preparation of the body, as we've said, lasted about 70 days, of which the major part was devoted to mummification. The first mummies probably came about by chance. Bodies buried in the desert sand were preserved in an astonishing way because of the heat and dryness. Impressed by these almost intact bodies which the wind exposed from time to time, the Egyptians sought to reproduce this phenomenon voluntarily, convinced that perfect conservation of the body was an essential requirement for life in the hereafter. Mummification procedures were already well established during the Old Kingdom, to which Khufu belonged. The Egyptians quite understood that humidity was the #1 enemy of conservation of the body. After purification, the intestines were removed from the body. An essential component of mummification was then introduced: natron. This is a sodium salt that's formed naturally in certain lakes. The Egyptians had noticed its properties as a drying agent. And so the viscera were washed, placed in 4 vases, the canopic jars, then dried using natron. As for the body, it was stuffed with linen and sawdust impregnated with natron, and it was also plunged into a natron bath. Only the heart was left inside, the seat of thoughts and feelings. Later, it was sometimes replaced by a golden scarab. In this way, the body was dehydrated by the action of the salt, preventing any decomposition. After 30 to 40 days, the natron was removed from the dehydrated body. The abdominal cavity and thorax were filled with cloths impregnated with aromatic substances. Balms and perfumed oil were applied to the body to restore a little suppleness to the skin. We move on to the wrapping. The body of Khufu was wrapped in strips of linen, starting at the extremities, the hands and feet. For so big a king, up to 7 layers of the finest linen were used. The total area of fabric used could reach almost 400 square meters for such a high personage, and the wrapping could take about 2 weeks. Between each pair of layers, magic amulets were placed, destined to assist and protect the king in the afterlife, while the high priest chanted prayers. The mummy was then wrapped in a shroud and placed in a wooden sarcophagus. Khufu was ready to go to his last resting place. Khufu left the lower temple with his procession of officiants and mourners and was carried up the covered royal causeway. This progression in the shade symbolized that of the sun during the night. Like the sun, Khufu had to confront dark forces to carry out his emergence into light and be reborn. Just as Nut, the goddess of the sky, swallowed the sun in the evening to give it rebirth in the morning, Khufu disappears into the dark, covered causeway. We see him again emerging and entering the upper temple, which backed onto the pyramid. Some more rituals before proceeding inside for the burial proper. Like all the deceased, Khufu had to appear before Osiris. For this purpose, and also to pursue his afterlife, it was necessary to give him back his senses, and therefore to reopen the 7 orifices in his head. The high priest, or certainly the elder son of Khufu, started by burning incense in a small scepter in the shape of an arm. This was the purification of Horus. Then several liquids and resins were poured onto the sarcophagus. This was the purification of Thoth. Finally, the nostrils were touched with an implement called a setep to return breath to the deceased, and then in turn the ears, the eyes, and lastly the mouth. Khufu was now ready to appear before Osiris for the weighing of the souls, where, his speech having been returned to him, he could make his negative confession. Leaving this ceremony to follow its course, we follow the officiants who were already transporting Khufu's funerary furniture into the pyramid. In fact, the Egyptians believed that the deceased had to find all the objects necessary for everyday life, from furnishings right down to the smallest ordinary objects, in the afterlife. The funerary furniture was usually stored in antechambers adjacent to the burial chamber. And this is where the question arises of the observed departure in the Great Pyramid from the internal architecture of the preceding ones, especially Red Pyramid. As already mentioned, the internal plan of the Red Pyramid is remarkably simple. What's striking about that of Khufu's pyramid, besides its greater complexity, is the absence of antechambers. Some have assigned this role to the underground chamber or to the intermediate chamber known as the Queen's Chamber. However, the funerary furniture had to be readily accessible to the deceased, which then would not have been the case. Others then thought about the Grand Gallery, but its steep slope makes this hypothesis unlikely. So, why would the Egyptians have abandoned a plan that was so effective in the Red Pyramid? And why don't we find antechambers adjacent to the King's Chamber in the Great Pyramid? Jean-Pierre Houdin has studied all the pyramids of the 3rd and 4th dynasties. He perceived a logical evolution from one pyramid to the next in a handing down of knowledge. As the Red Pyramid immediately preceded Khufu's pyramid, it's probable that the designers of the former, or their immediate disciples, designed the latter. Therefore, there was no logical or practical reason to introduce a major change in the internal architecture of the new pyramid. Consequently, Jean-Pierre Houdin had the idea of inserting the same arrangement of antechambers as that found in the Red Pyramid into Khufu's pyramid, but raised to the level of the King's Chamber at a height of 43 meters and behind the Grand Gallery. This new arrangement worked perfectly in Khufu's pyramid. In addition, if we observe the result in space, it explains several curiosities in the internal plan of the structure, especially where the offsetting of the Grand Gallery is concerned. It does not lie along the monument's north-south axis, since the antechambers are on this axis. Similarly, the twisted shape of the shafts from the Queen's Chamber and the King's Chamber becomes logical if these shafts had to bypass the antechambers and the passageway that connected them to the King's Chamber. If we assume that Khufu's pyramid reclaims its antechambers, the true funeral circuit, which Jean-Pierre Houdin calls the noble circuit, becomes quite different. Therefore, the entrance in the eastern corner of the northern wall of the chamber that visitors use today is not the one the Egyptians built for the funerary procession to use. The true entrance was cleverly concealed in the western corner of the same wall. If we look carefully, we can see that the red stones form a portico which supports the load of the ceilings installed above. The yellow stones, in contact only with the red blocks of the portico, are simply infill and do not cause any load on the stone that's underneath. This block is therefore free of any load, which means it can be moved. We can still see today, if we visit the King's Chamber, that the joints between the stones of the wall are perfect, with not enough room to slip a razor blade between them. On the other hand, in the vertical joint between this block and the neighboring block to the right, you could insert a credit card. Moreover, microgravimetric analysis in 1986 detected a clear zone of low density in this area. Let's now go through this block and follow this small passageway behind it. We descend and penetrate into the first antechamber, in which some of the funerary furniture was stored. The passageway connecting the two antechambers that we're going through now is exactly on the north-south axis of the pyramid. Now we enter the second antechamber. Both have corbelled vaults, just as in the Red Pyramid of Snefru, Khufu's father. Now we can see the cross-section of the pyramid that unveils the new funerary architecture. We will also observe these elements in a series of views generated by the CATIA 3D scientific software showing these various elements. We can see the known internal architecture of Khufu's pyramid in green in this 3D model. We first need to enter the pyramid and gain access to the new funeral circuit. At the entrance to the pyramid and providing access to the new circuit, we find two small new rooms in purple. They are connected by a short vertical shaft to the ceiling of the descending corridor leading to the underground chamber. Later we'll see signs of these rooms on the face of the pyramid. Starting from these rooms, there's a first horizontal corridor in yellow rejoining the Queen's Chamber. Next comes a second ascending corridor in yellow leading to the antechambers. We cross the two antechambers in red before climbing towards the King's Chamber. Starting at the second room, at the pyramid entrance, there's a vertical shaft. We shall see that this shaft rejoins the internal ramp. we see a new corridor leading to the Queen's chamber, parallel to the one that we've seen. This corridor was detected by radar by the Japanese team of Dr. Yoshimura from the University of Waseda in the late 1980s. Let's look at the narrow shaft running north from the Queen's chamber. This shaft, according to the official surveys, bends for no reason that the conventional theory can provide. On the other hand, if one accepts the hypothesis of the antechambers, this corridor needed to avoid the access corridor to the first antechamber. The bend then seems entirely logical. The same goes for the other shaft, the one from the King's chamber. This shaft had to avoid a room that contained the mechanism to close the King's chamber. Again, we find a rational explanation for the turns indicated by the official surveys. So these antechambers, inherited from the Red Pyramid, fit perfectly into Khufu's pyramid without coming into conflict with the rooms and corridors that we know. Better still, they are integrated perfectly into the complicated layout of the shafts, for which they provide a logical justification. Now, let's look at the relieving chambers. In truth, these rooms do not relieve the King's chamber at all. Structurally speaking, the Egyptians could have built the roof in an inverted V above the first ceiling to take the vertical loads from the top of the pyramid. These loads are deflected sideways by this roof, a bit like water on an umbrella, and are distributed through the mass of the monument. With a single flat ceiling, this roofing would therefore have protected the King's chamber perfectly. As for the Grand Gallery, because of its sloping form, it could very easily have withstood the small loads transferred to it, working just like a buttress in a cathedral. On the other hand, if we assume the existence of these antechambers, we can see that the vertical loads deflected by an inverted V-shaped roof would have come to bear obliquely on their ceilings. And it's there that a big problem occurs. Because of their structure, the corbelled vaults of the antechambers can take enormous vertical loads, but they cannot withstand side loads at all. Consequently, it was absolutely necessary to transfer these oblique loads much higher up so that they could pass above the antechambers. This is the true role of the multiple ceilings of the King's chamber, and the relieving chambers do not relieve the King's chamber, but the antechambers. The yellow arrows show the deflection of the loads by the roofing, and the pink zone is totally relieved, which effectively guarantees the security of the antechambers. On its own, the choice of a flat ceiling for the King's chamber required the construction of the Grand Gallery as a slideway for a counterweight to hoist the granite beams. As this traction system had already been built, it also allowed this astonishing structure of 5 ceilings to be built, this time to protect the antechambers. But all this obviously cost a great deal in time, planning, and materials. The Egyptians were never to repeat the experience. Let's now look at the room by the entrance, which provided access to the various corridors. At the northern face, and some meters behind a common entrance by means of the descending corridors that we've seen, we find 2 successive rooms providing access to a new group of corridors built into the pyramid. Moving to the exterior of the pyramid, let's turn back to look at the facade. Above the present entrance to the pyramid, you can see a big hole at the place where this room is. You can also see a double pair of limestone rafters located well above the original entrance. Now, in architecture, the installation of such rafters is never arbitrary. They always serve to cover a void. This archive photograph indicates the position of the rafters in comparison with the corridor. The people indicate the scale. These rafters appear disproportionate in comparison with the size of the opening, and they're positioned too high up, especially since enormous beams already cover the corridor. We can also see that several pairs of rafters seem to be missing, 6 at the bottom and 3 at the top. All this proves that there really was a first room above the descending corridor. A second room is located just behind the big stone, with fluting that we can see under these rafters. Let's look closer at this fluted stone, for it could only have been put into position from inside the second room. Protruding strips of mortar on the outside prove it. Remember also that the Greek geographer Strabo, who lived at about the beginning of the 1st century, wrote, "A little way up one side, there's a stone that may be taken out. When that is removed, there's a sloping passage leading to the tomb. This is the moment to follow the funeral procession as it entered the pyramid, travelling down the descending corridor for a few meters. It then climbed a shaft into the first room and passed into the second. Climbing over the fluted rock, it reached the second ascending corridor, which it climbed up toward a new horizontal corridor that led to the first antechamber. Here we enter it, then pass through into the second one. The workers and the priests then had to climb this ladder and make their way up this corridor, and finally enter the funeral chamber by the concealed entrance in the northern wall. They proceeded with Khufu's burial and the closing of the sarcophagus of Aswan granite. The funeral procession then left the king's chamber. The priests and officiants followed this route in the opposite direction to emerge from the entrance. As for the workers, a dozen or so, they remained in the pyramid. They now had to seal the corridors, and especially this chamber, so that Khufu could rest there in peace for eternity. For the chamber, the Egyptians would use an inspired mechanical closing system installed in the bent pyramid. The stone that would close the room and be concealed in its northern wall was for the moment in a room behind this wall. Behind it, a second stone, and a third one higher up, just waiting to push the two of them toward the passageway. This wedge just needed to be removed for this stone to be pushed into the passageway, with the second one taking its place. By means of a wooden piston that they maneuvered by pulling on ropes from the bottom of the second antechamber, the workers pushed the block into the opening in the chamber's northern wall. This chamber was therefore closed from the exterior, and no one was walled up alive with Khufu. Having blocked several points on their way down, the workers pushed back the fluted stone, the Strabo stone, under the rafters between the two rooms at the entrance. Other workers sealed the entrance of the pyramid from the outside. You might think that their remaining colleagues inside the pyramid were now trapped. This was not so, because everything had been thought out when the pyramid was designed. Don't forget that the second section of the internal ramp passed just a few meters overhead. The workers simply climbed back up onto the internal ramp by way of a small shaft. Then they only had to descend this ramp to the base of the pyramid. They just had to seal the entrance, an easy operation because it was at ground level. Not far from the pyramid, a well was found dug into the bedrock, a sort of model that the Egyptians dug to perfect the details of the junctions of all the passageways. In this model, they dug a well above a junction, a detail that we do not see in the known corridors. Quite simply, because this is the one by which the last workers reached the internal ramp. In this old photograph, in addition to the probable entrances of the internal ramp, we can see several notches high up on the same horizontal line. Is it by pure chance that they're located at 43 meters from the base, at the level of the storage platform, later filled in, right where the internal ramp is horizontal? The Great Pyramid, therefore, has funeral chambers consistent with those that preceded it. Its construction, with the rudimentary technical resources of the time, emphasizes even more the tremendous intelligence of the Egyptian builders. They were completely motivated by one overriding goal, that of ensuring eternal life for their ruler, so that, alongside the gods, he could protect Egypt and its tremendous civilization. Judging from this pyramid, still standing after 4,500 years, and by the fascination that it arouses, we can say without doubt that they largely attained their goal.